All right, here's the second section of chapter 12, 12.2. We're going to talk about measures of central tendency. Before we get started, I have a few pieces of data here that might be kind of interesting. It says here that 338 is the average number of friends for a Facebook user. I had some old information that said 130. I guess that's increased to 338. Are you close to that? Or 12 is the average number of cars an American owns during their lifetime. That sounds like a lot, but if you kind of calculate, I think I'm up to 9 already. 300 is the average number of times a 6-year-old laughs each day. Aw, that's sweet. 550 is the average number of hairs in a human eyebrow. Unless you consider my dad, then he's got like triple that amount. And 6 million is the average number of dust mites living in your bed. Ugh. These numbers represent what is average or typical in a variety of situations. In statistics, such values are known as measures of central tendency because they're generally located toward the center of the distribution, so kind of in the middle. In this section, we're going to talk about 4 different measures of central tendency. We're going to talk about mean, median, mode, and mid-range. The first one we're going to talk about in this video is what we call the mean. Well, more often than not, we use the word average to represent the mean. And hopefully we know what average means. Average means you're going to add up all of your data items and then divide by how many items that you have. And so the book uses this formula where we have this sigma notation. It's a summation symbol. It tells us that we're just going to add up all of our items and we're going to divide by however many numbers that we have, how many items we have. Or I always like to put it in my own words, and I'm just going to say we add up all the data and divide by the number of items that we have. That gives us our mean or our average. So I want you to look at this example with me, and we're going to first compare the data items, and then we're going to find the mean for each of the data items. And so in example number 1A, we have the data values 10, 20, 30, 40, and 50. In B, we have 3, 10, 10, 10, and 117. Okay? Let's say that these data items represented 2 different weight loss groups. Let's say, I don't know, Jenny Craig and Weight Watchers. And so if you look at the data items in part A, they're pretty close together. Somebody lost 10 pounds, somebody lost 20 pounds, all the way up to 50 pounds. In set B, somebody only lost 3 pounds, where one person lost 117 pounds. So that range is widespread. The data items look very different. But what if I asked you to calculate the mean for each of these sets? Remember, that's adding them all up and dividing by however many items we have. So I would like you to do that. I would like you to add up all the items, and I would like you to divide by however many items we have. So in the first case, it was 5. You should end up getting 150 as your total. Dividing it by 5 gives you a mean or an average of 30. So in this group, what did I say this was? Weight Watchers? We could say that the average weight loss was 30 pounds. Okay. In our second group, if we add them all up and divide by however many we have, we also end up getting a total of 150. When I divide that by 5, I also get an average of 30 pounds. So without lying, I could say that the average person in, I can't remember Jenny Craig Weight Watchers in set B also lost 30 pounds. But if you actually look at the data set, only one person even got close to losing 30 pounds. It was that person, that outlier, that lost 117 for whatever reason. All of the other people, the most that they lost were 10. And so you have to be really careful when you calculate or hear the word average or mean, because it doesn't always reflect all the different data items that are in the set, because there might be outliers involved. So you just have to be careful. The mean happens to be the same on both of these, but it doesn't really best represent the data items in part B as closely as it does in part A. So you just have to be careful when you calculate the average or the mean. Okay? All right, we're going to do another example in this video, example number 2, where we're going to get a little more complicated. Instead of just giving you a set of data and asking you to calculate the mean or the average, I'm going to give you a frequency distribution. So kind of like we did in the first section of this chapter. What if I gave you this frequency distribution table, and it says here the table at the right shows the students' responses to the question, how stressed have you felt in the last 2.5 weeks on a scale from 0 to 10? With 0 being not stressed at all and 10 being as stressed as possible. And so they went through, they asked a whole bunch of people how stressed they felt, and they've gone from a 0 all the way to a 10, and they've calculated how many people said they were stressed at a 0. That was 2. One person said they were stressed at a rate of 1, 3 people said they were stressed at a rate of 2, and so on. So you can see in this frequency distribution chart what their scores were and how many people said that score. Now, using this frequency distribution chart, can you find me the mean or the average stress level rating? Now, remember, mean means that we're going to add up all of our data items and we're going to divide by however many items we have. It's a little bit more complicated, though, when they don't just clearly give us the data items. When they give it to us in a frequency distribution chart, it's a little harder, okay? But what I want you to do is think about what's happening in this frequency distribution chart. I have a score of 0, and how many students had a score of 0? 2 of them, right? And how many students had a score of a 1? 1, right? And so what I started doing is I started kind of listing out what the scores were. Now I can't possibly, I guess I could possibly, but I don't want to write out all of the different scores, but I want to just kind of get started so I can kind of visualize what's happening. I have 2 students that scored a 0. So here's a 0, here's a 0. I have 1 student that had a score of 1. I had 3 students that had a score of a 2. That's a 2, 2, 2, and so on. And so when we go to find an average or a mean, we have to add all of those scores up. And so if I were looking at this set of zeros and I were to add those up, what's 0 plus 0? Well, isn't that just 0? Or can I say 2 times 0, which is still just 0? And if I added up the score of 1, well, 1 times 1 is just 1. And so far I have 1 plus 0. I'm going to add up all the 2's. 2 plus 2 plus 2, or could I say 2 times 3? Isn't that the same thing? And say 6. And then I'm going to add up all the 3's. Well, how many 3's were there? Weren't there 12 3's? So instead of doing 3 plus 3 plus 3 plus 3 12 times, can I do 3 times 12? Well, what I'm going to do then, I don't know if you've noticed this pattern, is I'm going to take the frequency distribution chart and I'm going to multiply the score by however many students said they were that stressed. So 0 times 2 was the 0, 1 times 1 is 1, 2 times 3 is 6, kind of like how we did over here. I'm going to do the same thing with 3 times 12, 4 times 16, 5 times 18, and so on, so that eventually I can add all of those up. That's adding up all of our data items. So I'm going to do 3 times 12, I'm going to do, oops, I lost my 6. I'm going to do 4 times 6, and so on. And so hopefully your numbers match mine. Now that I've multiplied them all together, that gives me the 0, that gives me this 1, that gives me this 6, that gives me this 36. Don't I still have to add all of those numbers up to get a total? So now what I want to do is I want to add up all of those numbers so I can get a total. Remember, finding the mean or the average means I'm adding them all up and dividing by however many there are. So when I add up all the scores, I end up getting a total of 975. Now I've got to divide by however many students there were. How many scores did I have? And so how am I going to figure out how many students I surveyed? Well, remember, the frequency gives us how many people said each score. So I should be able to add up all of these to figure out how many students I surveyed. So 2 plus 1 is 3, 3 plus 3 is 6, and so on. And I ended up getting a total of 151 people that were in my survey. I add up all the scores, that's a 975, and I divide by 151. That's how many students were in my survey. I'm going to take that and I'm going to divide them to get my mean or my average. I ended up with 6.47. So what that means is the mean or the average stress score was a 6.5. Well, somewhere between a 6 and a 7, right? So I can say it was about between 6 and a 7 stress rating. Okay? Kind of difficult, so I need you to make sure that you process that. Make sure that you run through the video one more time if you need to. But really, we're adding up all the items and we're dividing by however many items we have. Okay?